well, in lesson 6.5, decomposing bases for area, we will be calculating the volume of prisms with complicated bases. Just a reminder that a prism is a three-dimensional shape that has two bases that are identical, and then height that is made up of faces, which are typically rectangles, and that prisms are named for their base. So this is a pentagonal prism because its base is a pentagon or a five-sided polygon. So for this lesson, I'm just going to run through one complete example of a prism with a more complicated base than we have been working with, and then you guys can jump right into journal problems. So here we have a pentagonal prism, and we are being asked to find the volume of that prism. So just a reminder that volume of right prisms are the base, the area of that base multiplied by the height of the prism. So the best first step is to identify what that base is. And when I was first learning how to do this, that was the hardest part for me because I always wanted to think of the base as what was sitting flat against the surface. But let's remember that bases are identical and then they are connected by the height or by a series of rectangles. So in this case, our base is this figure right here, and it is a pentagonal base because it has 5 sides. So your second step for these ones is going to be to identify the composite shape that is the base. So that we can then calculate the area of that base. Okay, so I've also included just a really super not to scale rough sketch of what this base is going to look like, and now I'm going to start including my dimensions. So I have this 3 centimeters up here. Okay, I don't know what this length is right here, but I know right here is 2 centimeters. I know that right here is going to be 7 centimeters. And then this length right here, I can pop all the way back right here and see that that is going to be 5 centimeters. Okay, now I can start breaking this up into shapes and finding the area of those shapes. So right away, what I see is right here, I have a rectangle, and my blue rectangle is 3 centimeters. So there's a 3 cm right there by 5 centimeters. And then I see that I have another rectangle right here. And that one is 7 minus 3. So that means that this has to be 4 centimeters by 2 centimeters. And that leaves me with a triangle that is a right triangle. And its base is 4 centimeters, and its height is 5 minus 2, so its height is 3 centimeters. And I'm going to actually just break those pieces apart into separate pieces and then find the area of each. So my area of the first rectangle is going to be 5 times 3, so this is going to be 15 centimeters squared. And then I'm going to go ahead and do my other rectangle. 2 times 4 is 8, so this is 8 centimeters squared. And then for my triangle, again, area is 1/2 of your base times your height. So this is going to be area is 1/2 4 times 3, or area is 1/2 of 12, so area is 6. So this is going to be 6 centimeters squared. And so the total area of my figure is, adding those all up together, so we're looking at a total area of 29 centimeters squared for our base. So our next step, Number 4 is we want to then calculate the area of the base by the height of the figure. So volume is 29 times the height, and in this case, the height of our figure is 8 centimeters, because that is this length right there. Therefore, that's that length this whole way. So 29 times 8, volume is 232 centimeters cubed, because we now have length, width, and height. So we are working in 3 dimensions. All right, there you have it. All right, grab those journal problems, give them a try. Let me know how I can help you. Thanks, y'all.